Hello again, peeps. Thank you for joining me today for today's topic, which is on something called scientific notation. And our root word here, we got scientific. We're talking about science-based things, and notation is just a fancy way to say how you write it. So we're really learning how do we write numbers in science. So within science, numbers become very, very large, and we're talking about the universe and traveling across those distances, and numbers also become very, very small when we start talking about the molecular level. And we need different ways to express these numbers that are easier for us to read. And the way that is it's called, we're going to write numbers in scientific notation. So let's start with some examples here. And the first thing we're going to say is we are going to write the following in scientific notation. All right, let's do some examples here. So for example A, I'm going to say we have this number right here. And some of you may look at that number and recognize right away. This is 3,200,000. And what we're going to do is write this number in scientific notation. Scientific notation is based on writing things in base 10. So I want to know how many tens are in 3,200,000. The way I can tell that is I know the decimal begins right here. And what I'm going to do is I'm going to count how many spaces I can move it over until the number in front is larger than 1 and less than 10. So as I move this over, I move it over 1, 2, 3, 4, 5, 6 places. So I moved it over 6 times. So the decimal is going to move in between this 3 and this 2. So it's going to be 3.2 times 10. And then how many tens are there in 3,200,000? Well, I moved the decimal over 6 times, so there are 6 tens. And if you recall, when you multiply something by 10, you can simply move the decimal over 1 or add a 0 in order to figure out what that is. So this is 3,200,000 written in scientific notation. Now it's important to realize this is just a different way of writing this. These are completely equivalent. It's just a different way of writing it. All right, let's do another example for that. So this was an example of a large number, which is not too large, but you could imagine if I had 23 zeros, that it's just easier to read to the 23rd power versus to all those zeros and figuring out how many there are. So for letter B here, I'm going to give you a very small number. And when we get numbers that are very small and we have all these zeros, they're also difficult for our brains to process how small these are and to make comparisons. How many zeros does this have? Well, we could count, but if it had an extra 0 or 1 less, it's hard to tell which one's larger or smaller. So in order to turn this into scientific notation, again, I'm going to focus on the decimal. And I need to move the decimal until it's going to get to this in between 5 and 6, because I always want this first number to be between 1 and 10. So I'm going to move it over and we'll just count. 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, but be careful with this. Since we're moving the decimal to the right, that is going to create a negative exponent. So this would actually be 10 to the negative 8th power. And this is how we would write an equivalent number. Again, these are equivalent in a different form called scientific notation. All right, let's do some more examples here. Let's go the opposite way. So let's write the following numbers. Let's write the following in standard form. And standard form is just our regular number system. So this time I'm going to give you a number written in scientific notation. Let's say 7.2 times 10 to the negative 6th. We're going to write this number in in standard form. All right, so I'm always going to start with my regular number. So it's going to start with 7.2. And what is this negative 6 going to tell me? Well, first of all, it's going to tell me I'm going to move my decimal to make this a smaller number. The negatives are going to move it to the left. How many times? I'm going to move it 6 times. So I'm going to move it 1, 2, 3, 4, 5, and 6. I'm going to put a decimal there, and I'm going to put a 0 out front. Now, for every space, I'm going to place a 0 in there. So there's 1, 2, 3, 4, 5 spaces. So this is going to be 0.00000072, and that is that number in standard form. Again, it's equivalent. They're just written in different forms. Let's do another one here. Let's say we're going to write the number 4.3 times 10 to the 5th power. And likewise with this, when it was negative, I need to move that 0 to the left. When it's positive, I'm going to move it to the right. So I'm going to start with 4.3. I'll put my pencil on the decimal, and I need to move that decimal 5 times to the right. So it'll be 1, 2, 3, 4, 5. I'll put a decimal there, and I don't need to put a 0 after that. But likewise, for each space, I'm going to put a 0 in. So this ends up being 4, 3, and we got 1, 2, 3, 4 zeros. And I think that's going to give me 430,000. Okay, and that's just a bare bones instruction of how we turn numbers into scientific notation and how we turn numbers into standard form. There's certain numbers that are important within scientific notation. So we're going to talk about those a little bit. And in this case, we're going to write the following numbers out in words. All right, we're going to start with 10 to the 1st power. And when we're talking about 10 to the 1st power, we're talking about 10. So for example, if I said 3 times 10 to the 1st power, really, that's just like saying 30 in a different way. And when I say 10 squared, we're really talking about 100. So if I had 3 times 10 to the 2nd, it would be 300. In this case, it'd be 3 tens, but we really just say 30. And as we work our way down, we're really talking about adding zeros every time. This has 1 0, this has 2 0, which is why it's 100. This has 3 zeros, and we should know 3 0 is going to be 1,000. So again, if I had 4 times 10 to the 3rd, it means 4,000. When I have a 4th 0, that's going to be 10,000. When I have 5 zeros, it's going to be 100,000. I'm going to grab a different marker because this one's drying up on me. 10 to the 6th is a big stopping point because now we're talking about million. 10 to the 7th then is going to be 10 million. 10 to the 8th is 100 million. And then we're going to go 10 to the 9th. It's another big one because now we're turning into billion. 10 to the 10th is going to be 10 billion. 10 to the 11th is going to be 100 billion. I'm running out of room here. I don't know how far down I can go on the camera. I'm going to do it over here. And 10 to the 12th is going to be trillion. Okay, the major ones that we want to know 10 to the 6th is a million because then I know 7 and 8 are 10 million and 100 million. 10 to the 9th is 9 zeros. I know that's a billion. And when I add another 0 to it, or the 10th 0, I know it's 10 million and 100 billion. When I get to the 12th, we're talking about another one. We're talking about trillion. And after that, we would have 10 trillion and then 100 trillion, etc. All right, so that's the basics of scientific notation. Biggest things you need to be able to do. Take a number that's written in standard form, turn it into scientific notation. Take scientific notation, turn it into standard form. And then just becoming familiar with these words. If I say million, realizing that's 10 to the 6th power. If I say billion, realizing that's 10 to the 9th power. All right, that's all I have for this topic. Good luck on those problems this evening.